So here is Stream Studio, an Eclipse-based development IDE for developing Streams application. I have a couple of projects here containing my Streams applications, and the IDE provides a graphical editor that allows you to construct a streaming application using simple drag and drop. A Streams application is made up of a set of operators that process the data flowing through the application. So the graphical editor provides a palette that contains the operators that you would want to use, that you simply drag and drop it into to create your application. You connect them and you configure the operators to process the data as you wish. And then down here we have what we call an application graph view that allows you to visualize the topology of your applications. So each box here represents an application. And for our prototype, for the Streams application, we actually wrote 3 separate applications that are interconnected. So each box here represents an application. And what you see here is a very typical organization of a streaming application, in that there's usually an ingestion step where you get data into the system, into your application, followed by one or more applications that does the analysis on the data, and then usually followed by a set of applications, or could be in the same application, where you take action based on analysis that you've done on the data. So in our case here, this first application here ingests the device events made available by the IoT connector application that we have running, that provided connectivity to the IoT platform service, where the Pi was sending the sensor information. And then our application, the analytic application here, gets that data provided by, made available by the ingestion application. It does the required analytics, like checking the weather forecast, querying business rules to determine water governance on the water usage, followed by publishing the decision in the form of a command back to the device. So that's the topology of our applications here. Now let's take a closer look at our ingestion app. This application uses an operator provided by the IoT toolkit that I had mentioned earlier to subscribe to device events of interest. So it's a matter of using an operator that the toolkit makes available, and you just configure the operator to say what device events you want to subscribe to. And that makes the device events available to the application, and then we use another operator also offered by the toolkit to extract the application data out of the device event information and make it then available to the rest of the Streams application using an export operator. If you remember what Samantha had shown, the device event data comes through as in JSON format. So what this extract operator does is it gets the JSON, extract the application data out of it, and convert it into what we call a Streams tuple that can be used by a streaming application. And next here is our analytics application, which does the required analytics on the data that comes from our sensors, from our devices. So this export operator here made the sensor information, device events available to rest of our application. And this is an import operator that connects to that export to get the data flowing through this side of the application. And as you've seen in the demo that Kendrick did, the part of the demo that Kendrick did, we could get real data information from the Watson IoT Watson Insights for Weather API, which would get you the real weather information. Or we also had a weather god to simulate weather, so that we could actually do our demo. So this operator here does a check. That is essentially a router that checks to see which weather information we should be using. And then based on the check, we would either get information from the real weather information from the Watson Insights for Weather API, or get it from the simulated, from the weather god, the simulated weather information. Once we have the weather information, we then pass it along, and further along in our application, we check business rules to see whether there are any bans or water bans in the affected area, and taking all of that information into account, a decision is made, and that decision is then routed to both the UI. So this part here routes the decision to the UI, so we can see the UI getting updated with the decision, and it also routes it to the device through an export. Down here you see a sort of like a standalone operator, and what that operator does is it periodically checks the our application to see if there's a water ban. So, and if there is a water ban, it relays that information immediately, and it gets relayed back to our device. So how does the decision and the water ban information get to our device? We have another application here, which takes the information, which connects to our export operator here that contains the decision information. And then we scrub the data, and we convert the data, the decision, which is the data, into a JSON format that can be sent back to our device. And the payload in that JSON contains the decision that, sort of the information that our Quarks application is expecting. And then this is another operator that comes with the IoT toolkit that allows you to publish that event or command back through our connector application, which goes through then the IoT platform service to relay it back to our device itself. All right, so and that completes the whole circuit from the Pi generating the event, our Quarks application making that event available through the IoT platform, it coming into the Streams application that makes the decision as to whether the sprinkler can turn on or not, and then the command gets relayed back. So the decision gets relayed back as a command. And if you step back to look at our organization of our application here, what you'll notice is that the ingestion and the command app can stay pretty standard, constant. I mean, as in you just need one application to get the sensor information, and then one application that can publish commands back to the same device. And you can plug in as many analytics application as you want that processes and analyzes the events that's coming from the device. And they can all connect back and send commands back to the device as necessary. And that's just how simple it is. And it's literally plug and play. So, and that is all that I have to show from the Streams application side of things. I will now hand it back to Samantha to wrap up the webcast.
Thank you, Mary. Can you please show the charts?
Okay.
So thank you for everyone for watching. I hope you have enjoyed our demo and our tutorial. Before we end the webcast, here are some resources to help you get started. For information about Apache Quarks, visit our site at quarks.incubator@apache.org. For the material that we have presented today in terms of how to work with sensors on Apache Quarks and connecting to Watson IoT Foundation and also receiving commands, we have created 2 recipes on developer works. So check it out there if you want to start writing your own application. It will give you step-by-step instructions on how to write one of these applications. For more information about IBM Streams and our Bluemix streaming analytics service, here's are the resources to help you get started, which allows you to do real-time analytics for analytics. And last but not least, if you want information about our IoT platform service, here's a link for you to get started on how to work with Internet of Things. And that is the end of our webcast. Thank you very much for watching.